Hello students, I hope that you are good, well and fine. In today's session, we will be seeing miscellaneous exercise of chapter 11, three-dimensional geometry. Okay, so very straightforward exercise. Let's see quickly. So first problem, find the angle between the lines whose direction ratios are A, B, C and B minus C, C minus A and A minus B. Okay, so you are given with two lines having direction ratios as these. Okay. Now you have to find angles. In order to find angles using direction ratios, you know the formula. So formula says cos, if Q is your angle in between your lines with direction ratios given to you, so cos Q will be absolute value of, okay, or A multiply with B minus C plus B multiply with C minus A plus C multiply with A minus B divided by root of A square plus B square plus C square plus, okay, so here it must be multiplication sign. Okay, so root of B minus C square plus C minus A whole square plus A minus B whole square. Okay, the multiplication sign must be here. Clear? Okay, now what is happening that, okay, so this gives you what? This gives you what? If you simplify it, what you will have, as you can see, AB will be cancelled with this AB, AC will be cancelled with this, okay, and then BC will be cancelled with this. So this means numerator will become 0 and then you will have cos Q as 0. This means Q will be, your angle will be of 90 degree. Means both of your lines will be of, or both of the lines must be perpendicular to each other. Okay, clear? Simple. So what you have to just remember the formula. You must remember the formula. Okay, whenever direction cosines are given to you, you must know this formula. Okay, just multiply the corresponding components, okay, and then add up. You will form your numerator, and in order to find your denominator, sum the squares of the direction cosines and make it root. Okay, clear? I hope it is clear to you. Okay. Okay, so I hope that it is clear. Sorry, not cosines here. Must be ratio, direction ratios. Okay, direction ratios are given to us, not cosines. Sorry for that. Okay, direction ratios. Okay, not cosines, ratios. Now let's move next. Now second problem. Find the equation of a line parallel to x-axis and passing through the origin. So you have a line parallel to x-axis and passing through the origin. Quite simple to write. So you know that the line parallel to x-axis and passing through the origin is x-axis itself. Yes. So A be a point on x-axis. Therefore, the coordinates of A are given by A, 0, 0, where A belongs to any real number. So direction ratios will be what? A for OA. Okay, for OA will be A, 0, 0. Clear? I hope it is clear to you. So direction ratios, how can you find? Very easy. O represent your origin, A represent this point, A, 0, 0, and you know the direction ratios can be find out by using just A minus 0, 0 minus 0, 0 minus 0. This means A, 0, 0. Now equation will be what? Quite simple. That your line now will be what? As you can see, will be parallel to this. Yes. So this means equation will be x minus 0 divided by, same as y minus 0 divided by 0 equals to z minus 0 divided by 0. This gives you x by 1 is equals to y by 0 is equals to z by 0 is equals to some scalar A. Thus the equation of a line parallel to x-axis in the Cartesian form through the origin will be x by a is equals to y by 0 is equals to z by 0. Clear? Okay. Now, third question. If the lines x minus 1 divided by minus 3 is equals to y minus 2 by 2k is equals to z minus 3 by 2, and x minus 1 by 3k is equals to y minus 1 by 1 is equals to z minus 6 by minus 5 are perpendicular, find the value of k. You have to find the value of k. So very easy. Both are perpendicular. This means you must have what equals to 0, and what expression must be equals to 0? If you multiply the corresponding component of direction ratios, you will get the sum equals to 0. This means, so direction ratio, first of all, the direction ratios will be minus 3, 2k and 2. And for this line, 3k, 1 and minus 5. Okay. And now minus 3 will be multiplied with 3. 2k multiply with 1. 2 multiply with minus 5. Must be 0. Okay. It is already given that both the lines are perpendicular. Just you have to find the value for k. So minus 3 multiply with 3k plus 2k multiply with 1 plus 2 multiply with minus k means 9k plus 2k minus 10 means 7k is equals to minus 10 means k must be minus 10 by 7. K must be minus 10 by 7. Therefore, k will be minus 10 by 7. Then you will have both the lines equals to, both the lines are perpendicular. Then both the lines must be perpendicular to each other. Now fourth, you have to find the shortest distance between these two lines. Okay. Now, quite easy. You know the formula for the shortest line. Cross product of b1 and b2. Dot product with a2 minus a1 divided by magnitude of cross product of b1 and b2. b1 is this I hat minus 2j hat plus 2k hat. b2 is 3I hat minus 2j hat minus 2k hat. a1 is 6I hat plus 2k hat plus 2j hat, 2j hat plus 2k hat. a2 will be minus 4I hat minus k hat. Okay. Now, a2 minus a1 will be minus 4I hat minus k hat minus what? 6I hat plus 2j hat plus 2k hat. This means you will have minus 10I hat, okay, and minus 2j hat and minus 3k hat. Okay, now what about the cross product? Very simple. Evaluate this determinant I hat, j hat, k hat. Second row 1 minus 2, 2. Third row 3 minus 2, 2 minus 2. This gives you what? Now evaluating this determinant, you will have I hat multiply with 4 plus 4 minus j hat multiply with minus 2 minus 6 plus k hat multiply with minus 2 plus 6. This means 8 I hat plus 8 j hat plus 4 k hat. The magnitude will be root of 8 square plus 8 square plus 4 square means 12. 64, 64 and 16 gives you 144 means root 144 gives you 12. Now the dot product, you will have dot product as minus 80 minus 16 minus 12. And this gives minus 108. So now your distance, shortest distance will be putting the respective values in here in this expression to get your shortest distance. You will have 9. So shortest distance will be 9 units. Okay. So the last problem of this miscellaneous exercise is saying that find the vector equation of the line passing through the point 1, 2, minus 4 and your line is perpendicular to the two lines given to you in the Cartesian form. One is this, another is this. Okay. So I'm hoping that this question you should try it by your own. Okay, so I'm not going to show the solution. I'm not giving you any kind of hint as we have already seen such problems. So it's time to evaluate yourself. So please try it. Okay. So this is it for the miscellaneous exercise. Now we will proceed. Let's see some summary about what we have learned so far. So summary quickly. So direction cosines of a line are the cosines of the angle made by the line with the positive direction of the coordinate axis. If L M N are the direction cosines of a line, then L square plus M square plus N square is equals to 1. Okay. Now the direction cosines of a line joining two points will be x2 minus x1 divided by pq, y2 minus y1 divided by pq, z2 minus z1 divided by pq, where pq, what is your pq? Pq will be the length from p to q, okay, which will be from root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Okay, clear? Now direction ratios of a line are the numbers which are proportional to the direction cosines of a line. Okay, if LMN N are the direction cosines and ABC are the direction ratios of a line, then L is equals to A by root A square plus B square plus C square. M will be B by root A square plus B square plus C square. N will be C by root A square plus B square plus C square. Okay, clear? Now, skew lines are lines in space which are neither parallel nor intersecting. They lie in a different plane. Okay. Angle between skew lines is the angle between two intersecting lines drawn from any point. Okay. Parallel to each of the skew lines. If LM, L1, M1, N1 and L2, M2, N2 are the direction cosines of two lines and theta is the acute angle between the two lines, then your cos theta will be absolute value of L1 L2 plus M1 M2 plus N1 N2. Okay. Now, if A1 B1 C1 and A2 B2 C2 are the direction ratios of your given two lines and theta will be the acute angle, then your cos theta will be A1 A2 plus B1 B2 plus C1 C2 divided by root A1 square plus B1 square plus C1 square multiplied with root A2 square plus B2 square plus C2 square. Now, vector equation of a line that passes through the given point whose position vector is A and parallel to a vector given B is R vector is equals to vector A plus lambda times B. Okay. And equation of a line through a point x, y, z1 and having direction cosines Lm and n, then you will have your equation in the Cartesian form as this: x minus x1 divided by L is equals to y minus y1 divided by m is equals to z minus z1 divided by n. Okay, clear? Now the vector equation of a line which passes through two points whose position vectors are A and B is R, the equation, okay, vector equation will be A vector plus lambda times B vector minus A vector. Okay. Now, if theta is the acute angle between these two lines in vector equation, then your cos theta will be dot product of these B1 and B2 divided by the product of magnitude of B1 and B2 and then whole modulus thing. Now, if x1 minus x1 divided by L1 is equals to y minus y1 divided by m1 equals to z minus z1 divided by n1 and y minus y2 divided by m2 is equals to z minus z2 divided by n2 are the equations of two lines. Okay, are the equations of two lines, then the acute angle between the two lines is given by this expression. We have just already seen this expression above. Okay. Now, shortest distance between two skew lines is the line segment perpendicular to both the lines. Okay. Now, shortest distance between given two lines in this form, you will have cross product of B1 B2 dot product with A2 minus A1 divided by the magnitude of the cross product of B1 and B2. Okay. Now, shortest distance between these two lines, if your line equation of the line given in Cartesian form, then you will have determinant of x2 minus x1, y2 minus y1, z2 minus z1 as your first row of your determinant, a1, b1, c1 second row, a2, b2, c2 third row for your determinant, divided by root of b1, c2 minus b2, c1 whole square plus c1, a2 minus c2, a1 whole square plus a1, b2 minus a2, b1 whole square. Clear? Now, distance between parallel lines. So, distance between parallel lines are, if your both the lines given in this vector form, your equation given in this vector form, r is equals to a1 vector plus lambda times b1 b, and r vector is equals to a2 vector plus mu times b. Okay, so you all know that whenever you have two parallel lines, this means these b vector must be same. Okay, or scalar multiple. Okay, now here the distance will be b cross product with a2 minus a1 divided by magnitude of b. Okay, so this is it. All of these we have already seen in the theory. We have here we just summarized all of the main important forms, main important formulas, main important key things, so that you know what we have learned so far, what are the key points from this chapter, what you must have to remember, what you must have to memorize, what formula to use, when to use. Okay, so this is it for now. I hope that you understood everything, and please do try the fifth problem of this miscellaneous exercise to evaluate yourself. Okay, so thank you. We will be back with new chapter. Okay, so again, thank you.